Welcome to part 3 of the Hyperbola video series on conic sections. In this video I'm going to go through two big examples where we graph equations that aren't necessarily in the hyperbola form to begin with, and I'll also give you two opportunities to practice on your own. So right now, if you feel that you're pretty comfortable with completing this square, maybe pause this video and give this one a shot. You're trying to get this into the correct format. And if you've been watching part 1 and 2, you know what the hyperbola equation looks like, and you can probably give this a shot on your own, but if not, here we go. I'm going to group my terms by variable, so I'm going to get the x's together and I'm going to get the y's together, and next I need to complete the square. So let's take a 4 out of here. We get x squared minus 12x, leave a space. I'm going to go minus 9 y squared, this should be a y right here, y squared minus 8, my computer is frozen here, y squared minus 8y, leave a space, plus 144, leave a couple spaces, equals 0. So when we complete the square, right, we're going back to like an algebra 2 lesson here where we take that middle term, divide it by 2, and then we square it. And that number gets added right here. Now since we added a 36 and it gets multiplied by 4, on the left side of my equation, I need to sort of account for that and counterbalance it. So 4 times 36 is 144. That was a plus 144, so I need to subtract 144 from the left. Do the same process right here. I'm going to take negative 8 and divide it by 2, and then I'm going to square it. So plus 16 goes right here, and again we're going to multiply that by the 9 in front, actually a negative 9. So that is, let's see, 90 plus another 54, so that's actually a negative 144. If we right there are subtracting 144, I need to counterbalance that by adding 144. Now it's just kind of by chance that these are both the same number, really. It doesn't always have to be that way, but let me get rid of this blue stuff and we'll continue here. We want to now factor, I'm going to factor this quadratic, x minus 6 quantity squared, and y minus 4 quantity squared. And this right here, plus 144 minus 144 plus 144, of course, will leave us with a plus 144. I want to get that 144 over to the other side, so let's do that now. Comes a negative 144. And we're of course at on the right hand side of any hyperbola equation you want the number 1, so let's divide everything by negative 144. So divide this by negative 144, divide this by negative 144, and this by negative 144. When you do that, you get 4 divided by negative 144, so maybe I'll take that over here. And we get, let's see, 3, that's 12, and another 24, so 36, negative 36 as our denominator. Negative 9 over negative 144, well, that's just going to be 16. All right, positive 16 though. So what happened is we have kind of an interesting thing going here, because originally what was a negative 9 now changes to a positive fraction, and what was originally a positive fraction changes to a negative fraction because we divided everything by negative. So really what we have to do is take this, move it to the front, and take this fraction and move it right. And when you do that, that's going to be a nice standard hyperbola formula format. So it's minus x minus 6 quantity squared over 36 equals 1. And from here we can really easily extract our center. Our center is going to be h comma k, which comes from right here, x minus h. So it's positive 6 and positive 4. Be careful not to reverse those. You have to really look at what letter is attached to the number and plug that into the correct position. This is h, k, x, y. And let's see, from there, let's see if we can get our a, our b, and our c. Lowercase a is always in the left-hand spot in a hyperbola. So if a squared is 16, a is 4. If b squared is 36, b is 6. And the relationship between a, b, and c in a hyperbola is a squared plus b squared equals c squared. So just plug this stuff in. C squared is equal to 16 plus 36. C squared is equal to 52. If c squared is equal to 52, c is equal to the square root of 52. And the square root of 52 has some factors. We're going to try to simplify this. So it's 2 times 26, 3 times, let's see, that would be 22, that doesn't work. 4 times, let's see, 13 maybe. 13 times 4 is 52, yep. So right there you can see that 4 is a perfect square. So I'm going to break 52 down into the product of 4 and 13. Split them up. The square root of 4 is 2. 13 is not a perfect square, so I'm just going to leave it like this. 2 radical 13. Alright, so we have A, B, and C, and we need to remember what those stand for. A is the distance from the center to the vertices. B is the distance from the center to the endpoints of the conjugate axis. And C is the distance from the center to the foci. And before we graph this, we have to have an understanding of which way it's going to be situated. Is the hyperbola going to be left and right like that, or is it going to be up and down like that? And that question is answered by taking a look at what is the lead variable in my numerator. It's a y, so that tells us that my transverse axis is going to be up and down. So it's going to look like this one. So let's put my center in there. I'll put my center in red, 6 comma 4. I already have my graph set up here. 6 comma 4 is right there. The distance from the center to the vertices is 4, so I'm going to go up 4. Up 4 will put me at 8. And down 4, of course, on the x-axis there. And let's see, we have B is the distance from the center to the conjugate axis. That's going to be this way. So we'll go 6 units to the right. So that'll put us at positive 12. And to the left at 0. And we're going to go with lowercase c, we're going to go up and down to our foci. So 2 radical 13 is, let's see, radical 13 is, it's going to be a little bit less than 4. So you might want to come up with some semblance of like a decimal, just to give yourself an idea of where to graph this thing. So if, at this point, if you want to use your calculator, you can just hit 2 radical 13 and you'll see that it's about 7.2. So I'm going to go up 7. So let's see, 1, 2, 3, 4, 5, 6, 7, plus a little bit more. And from the center, I'm going to go down 7. 1, 2, 3, 4, 5, 6, 7, plus a little bit more. So there we go. We'll come back and actually sort of write down all the coordinates of the vertices and the foci in a second. But let's graph this. And in order to graph it, we're going to need to know exactly where our asymptotes are going to go. And remember, the asymptotes are the asymptotes are basically going to be guided by this sort of conjugate rectangle here. There's sort of like an imaginary rectangle that is formed from the vertices and the green points, the endpoints of the conjugate axis, and at those corners I'm just going to put dots, because the asymptote is going to be, each asymptote is going to be guided by the center and that black dot. So what I want to do is very carefully draw in a dotted line that goes from the center to each corner, and same thing over here. And if you're working at home, you definitely want to use a ruler for that. And maybe I'll just get rid of that conjugate rectangle now. So now I can see pretty easily that I have asymptotes, and I'm going to extend them a little bit more. I have asymptotes that are guiding my hyperbola. This is going to tell me how sort of wide to make my curves. So I'll graph these in maybe a purple. It's going to go through each vertex and sort of try to hug this asymptote on each side. So it's going to look something like this. So this is a pretty wide hyperbola. Something along those lines. If you didn't have those asymptotes, you might be inclined to say that the hyperbola is kind of more shaped like this, which is not true. So you really need those asymptotes to figure out exactly how wide to draw your curve. Alright, in terms of the actual coordinates, this focus up here is, let's see, it's 6 units to the right, and then it's 2 radical 13 above my center. My center is at 4, so it's going to be 4 plus 2 root 13. This focus down here is 6 to the right, and then 4 minus 2 root 13. Those are exact values. The blue points, the vertices, are a little bit easier. This is my vertex, and that point is 6 comma, what was it, 8. 6 comma 8. And this other vertex is 6 comma 0. And let's see, we go to our endpoints of the conjugate axis, 0, 4, and 12, 4. And the last thing we're going to need, of course, is the equation of each asymptote. And to find that, we're going to use sort of a basic, let me delete some of this stuff. We're going to need sort of a basic equation that will give us the asymptote in y equals mx plus b. And the formula is pretty simple. It's y is equal to k plus or minus some slope times the quantity x minus h, and that slope is going to be determined by the what kind of orientation the hyperbola is in. If the hyperbola is in this format where the transverse axis is vertical, then think about this for a second. This number right here is lowercase a, and this distance right here is lowercase b. So rise over run is a over b. So we figure this out. We put in our k, which is h comma k is 4, plus or minus a, which is 4, over b, which is 6, x minus h, which is 6. And that gives, we have 2 equations that we have to account for. So let's find just one of them at a time here. We'll do, let's start with the positive. So over here I'll take 4 plus 4 over 6, and over on this side I'll take 4 minus 4 over 6. Since we have 2 asymptotes, we have to basically branch out and find 2 different equations. And we just sort of clean this up. 2/3 times quantity x minus 6. Distribute that 2/3 into there. So it's 4 plus 2/3 x. 2/3 of 6 is 4. So 4 minus 4 is 0. So it's just 2/3 x. That's one of the asymptotes. So I'll highlight that. And the other one, same thing, just clean it up. Minus 2/3 x plus 4. Remember, a minus and a minus distributes into a plus. So we have y is equal to 4 plus 4 is 8. So it's negative 2/3 x plus 8. And we can kind of confirm that with our graph too. You can see that the y-intercept is positive 8 and the other one is 0, and you can just simply do a rise over run. 2/3, negative 2/3, and you're done. The directions simply asked us to sketch the hyperbola and find the equations of the asymptotes, which we did. There's a lot of work there. This one started off with completing the square, so there's a lot to do, but again, hopefully having the advantage of watching these videos, and by the way, my videos are not the only ones on YouTube. One of the best sites out there, of course, if you can look at in my my profile, is Patrick JMT. His website is probably the best math one you can find on the web. Of course, Khan Academy also is sort of the leader in this online video stuff, but check those two out, and anybody else. If you just go to YouTube, search hyperbola conic sections and stuff, you'll find tons. So hopefully this is helping you out. Continue to use your pause and play strategy. Like for this one, for example, I want you to try this one on your own. So at this point, pause it and see if you can sketch this hyperbola on this graph. It's mainly going to reside in quadrant number 4. So pause it and give it a shot. And I'm just going to scroll down here and give you all the answers that you're looking for. I'm not going to go through this one, but this is what the graph looks like. I plotted your foci in orange, your center in red, and your vertices in blue. I put all of those coordinates right here. I also put the equations of the asymptotes, and I put a highlighted box around the equation itself. So pause that and check your work, see if you're right, and we're moving on to the next one. Our next example, number 4. This is going to be the last example I do. After this, I'll give you an opportunity to try one on your own, and then that'll wrap up the 3-part hyperbola video series. So in this one, I'm going to give you the vertices, 3, -5, and 3, 1, and I'm going to give you the asymptotes, and you're going to be required to write the equation. So let's plot these vertices, 3, 1, and 3, -5. Those are our two vertices. You can see that the transverse axis is vertical. In fact, the center is going to be right in the middle of those. If you wanted to, you can of course use the midpoint formula for that and confirm that in fact the center is 3 plus 3/2, -5 plus 1/2, and that'll give you 3, -2. So your center is 3, -2. You can see that on the graph as well. From there, let's draw in our asymptotes. We'll start with this one. +4 is your y-intercept, and we're going a slope of -2. So down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1. And we'll connect those dots with a dotted line. This is one of our asymptotes. Remember, this is how you guide how your hyperbola shape is defined. And the other one is -8 as a y-intercept, so that's actually down here somewhere. Up 2, right 1, 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 and we'll connect those dots as well. there are the asymptotes. Now, the next thing on the agenda, of course, is to figure out your lowercase a, b, and c values. And to do that, since we don't have any information about the foci in this problem, we have to have a really good idea of what the asymptote slopes actually mean. The asymptote slopes, in this case, the slope is 2. So if the slope is 2, in a hyperbola where the transverse axis is vertical, this distance is a, the distance from the center to each vertex. That distance is a. So it's rise over run, a over b. And I'm getting that from this general format. That general format tells us in a vertically oriented hyperbola, the slope of our asymptotes is rise over run, or a over b. So 2 has to be a over b. So if 2 equals a over b, and we already know a is 3, a is the distance from the center to the vertex. So you just kind of like match these numbers up, and you see that if 3 over b is equal to 2, then 2b must equal 3, so b must be 1.5, or 3 over 2. So that's how we get that value. And you can do the same thing over here. You'll actually get I think a negative 3 over 2, but it's same deal, right? And what that actually translates to is the distance from the center to the end point of the conjugate axis. So you just go over 1.5, go over 1.5, and the cool part about this is that you can sort of confirm that it works out, because it should form a nice rectangle, and it should form a nice rectangle, and it does. It works out pretty well, where the asymptotes sort of fit right in there. In other words, this corner, the corner of that gray box, should line up right on those asymptotes, and they do. They should also line up on these green points and these blue points, which they do. Everything kind of fits together nicely. So b is 3 over 2, and to get the c value, all you need to do is use your rule about in the hyperbola, the fact that c squared is equal to a squared plus b squared, and that'll give you the distance to from your center to your foci. So let's figure that out. So 3 squared is 9. 3 over 2 squared is 9 over 4. So c squared is equal to 9 plus 9 over 4. Let's get common denominators. 9 over 1 is equal to 36 over 4 plus 9 over 4. That's equal to 45 over 4. So c squared is 45 over 4. C is the square root of 45 over 4. And if we break those roots up, you can see that it's the square root of 45 over the square root of 4, which is the square root of 45 over 2. But the square root of 45 is not simplified all the way. That's 9 times 5. So you need to break the square root of 45 up into radical 9 times radical 5. So take it a step further. Radical 9, radical 5, all over 2 is 3 radical 5 over 2. 3 radical 5 over 2. And all that stuff right here, all this is basically just algebra, being able to work with exponents and square roots and all that stuff. Okay, so the distance from your center to your foci is essentially, you can rewrite that. I'm not going to do that, but this is how you can think about that. It's 1.5 times radical 5. And that's going to be the distance that you need to go up and down from your center. And if you figure this out approximately it's about 3.35. So it's up 3.5, like 3 1/3 units basically from your center. So I'm going to put those points in maybe orange. From the center, I'm going to go up 1, 2, 3 1/3, down 1, 2, 3 1/3, and the rest is basically just, you know, sort of sketching it. Need to go through. Again, I'm going to get rid of this gray box. I don't need that really. I'm going to go through each vertex and sort of hug the asymptotes. So it's going to look something like this. And down here, same deal. Something along those lines. And you might want to put coordinates for all these critical points here, and then we'll find the equation at the end. But the center is, let me get rid of all this stuff. The center is, let's see, what do we say, 3, -2. So I'll write that down. The center is 3, -2. The vertices, I think we were given the vertices, 3, 1, and 3, -5. The foci, from the foci are actually at 3, and then -2 plus 3 over 2 radical 5. 3 radical 5 over 2 rather. So it's -2 plus 3 radical 5 over 2, and the other focus is +3 comma -2 minus that. And those green points, if you wanted to find those, you can, these are like the endpoints of the conjugate axis. That would be over 4.5 units, down 2. And this point would be over 1.5 units and down 2. Okay, so we are really approaching the end here. We have pretty much everything. We have of course, the equations of the asymptotes were given. So now we just need the equation. To write the equation of a hyperbola that is vertically sort of oriented here, we know that the y term is going to be in the first fraction. This is a squared, so that's 9. This is b squared, that's 9 over 4. And this is y minus k squared, and the center is h comma k. So that's going to be y plus 2 squared and x minus 3 squared. And I think that ought to do it. I guess you can probably simplify this a little bit, but I'll probably just leave it just like that. And depending on what your teacher is really looking for, again, if you wanted to, you can, anything that's divided by a fraction, you can actually rewrite it like this. Dividing by a fraction is the same as multiplying by the reciprocal, so I guess that would be equivalent. But in my opinion, I think it's always smart to have this term right here to be a 1. So I think if it's my class, I think I'd rather the top one, but so I'll go with this one. So there you go. There's your equation of your hyperbola. That one's kind of extra tricky because of this craziness right here. I think it was kind of odd. All right, so try this one. Pause the video, give this one a shot. Again, I'm giving you the asymptote equations and the vertices, and your job is to sketch it, figure out A, B, and C, and then write the equation as well. All right, hopefully you gave that a shot. Here are your answers. You see that A is 1, B is 1, C is radical 2. And your equation is highlighted there for you. I also included the center coordinates and the foci coordinates. So there you go. That wraps up the Hyperbola 3-part series. Again, any questions or comments, just feel free to comment at the bottom here, and I'll try to get back to you. But wraps up all of these hyperbolas. And again, hyperbolas and ellipses have tons of connections, and yeah, we'll go from there. So thanks for watching, and I will see you in the next one.